Dear students, how are you? Hopefully you are well. This is Amit Saha, Lecturer, Department of Mathematics, Milestone College. Dear students, today we are going to discuss about chapter 1, that is matrix and determinant. Especially we are talking about determinant part, where we are trying to focus on the definition of determinant, minor, cofactor, and what is the basic thing we have needed to find out the inverse matrix. Actually, determinant is a very important part for our everyday life, which was invented by a Japanese scientist in nearly 1682. Later on, 1772, Laplace tried to give the expansion theory and the properties of the determinant. And 1773 is the time when the scientist Laplace actually shows how we can solve the system of linear equation with the help of determinant. So dear students, it's a very important topic and interesting topic for you. So let's have a look to this lecture. Dear students, so today our discussion topic is determinant, chapter number 1, whose name is matrix and determinant chapter. Actually, what actually the determinant is, and by or from where actually the determinant come, or from which part actually this determinant needed, we have to think about that. That's why we are thinking for a matrix first. Say for example, one matrix is say for example, suppose 2 3 and 5 6, and another matrix is suppose x y equal to, say for example, we can say it is 8 and 17. Suppose this is a matrix where these two matrices are multiple or multiplicable, and here it is a resultant value. So from this matrix, what we can say or what we can write from this matrix, if we are multiplying these two, then we will get what? Actually 2 5 x x plus 3y 6y is equals to 8 and 17. So actually from these two matrix we can write actually this part if we multiply, then we'll get this, and from here these two can be equal. So actually this matrix was formed by two matrices, and if we multiply or if we calculate these two matrices, then we can get the value of x is 1 and the value of y is 2. My dear students, my question is, if we can get the value of x and y from this equation, then how we can find the value of the value for the x y from this matrix part? That means if we are just thinking about the matrix, then which is the procedure to find out the value of x y without going this step? Then we can go from this part like this, that is x y is equal to, we can write 2 3 5 6. Since this is the, here is multiply, so if it is changed its side, it will be inverse and it will be multiplied with 8 and 17. Okay, so now my question is, we can find the value of x y if we multiply this part into this part, isn't it? So if we just think that this is our inverse matrix, and if we can let our assumption that this matrix is suppose 2 5 3 6 is a matrix is named as A. If it is A matrix, then how we can find the value for its inverse matrix? The actually value can be find of the inverse matrix by a formula, that is 1 by determinant of A into adjoint of A. Dear students, maybe one question arises in your mind that why we are going for inverse matrix, because determinant is the part it is come actually to determine that the inverse matrix or if a matrix is invertible or not, that is the part. So this is the actually area where actually the determinant part has been needed, and it is a very important part, or it is a very important area where determinant have to be found. Now here this is the lecture of not the finding the value of inverse in matrix, but this is the part where we are talking about actually determinant, and this is the place where determinant need, and this is the area where we are thinking for the determinant. Okay, so from this part we have to think 4 or 5 things. That is, what is this? This is the determinant of A. That means determinant of A determined that the matrix A is invertible or not. So here it represents the determinant. It represents the determinant, and from where we start our determinant part. Okay, and at the case of adjoint matrix we need 3 things. One is minor, second thing is cofactor, and third thing is transpose of that matrix. So if we are thinking for the inverse matrix, or if we are calculate a inverse matrix, we need to remember all of this part, and today this is the lecture only to understand all of this part. Okay, now we are discussing about the minor, cofactor, transpose as well as determinant. When we are thinking for finding the value of A inverse, there is another 2 things we have to actually clear to understand the basic actually. That is, one is identity of a matrix, and another thing is inverse. Identity of a matrix and inverse for matrix is what we have to have clear these 2 part when we are thinking for the inverse matrix. It will be discussed when we are talking about inverse matrix or finding the inverse matrix. This is the basic idea we need to have. Okay, so now we are trying to think to find a determinant. So we can already understand that determinant is something what is generally written as like this way. That means if we are talking about that, if this is our matrix, so the determinant of that matrix will be actually looks like 2, 3, 5, 6, and the calculation of the determinant part is generally this way. That is 2 into 6 is 12 minus 3 into 5, that is 15. So here it is minus 3, and since it is not 0, then we can say this matrix is invertible. This is the number 1. This matrix is non-singular is also. Okay, this is the not thinking for our this lecture. We are talking about what's the minor and cofactor of this matrix or determinant. Okay, what will be the minor? This is our present discussion. Okay, dear students, to understand the minor, we can assume that determinant is looks like A11, A12, A21, A22. Suppose this is a determinant where we are trying to find a what? Yes, minor. Actually, minor generally found by every entry. Minor can be found for the every entry. So minor of A11 entry will be what? When we are thinking about A11, that means for this region this and this will be gone, only remain this part. So minor of A11 will be A22. Similarly, when we are talking about, if we are thinking or if we are trying to find the minor of A12, then it should be, we are talking about this entry, that means this and this are just neglected, there will be remain one A21 and the A21, and the minor of this entry is actually this. Now, so the minor of A21 will be what? When we are talking about minor of A21, that means we are talking about this entry, so this and this will be gone, so remain that part, so it will be A12. And finally the minor of A22, that means we are talking about this, so this and this will be gone, remain this one part, that is A11. So this is how we can find the minor of a determinant part for the every entry is like this way. This is the 2 by 2 determinant. Dear students, now we are talk about 3 by 3 determinant, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is a determinant for 3 by 3 matrix. So from this determinant part, how we can find the minor. So if we are thinking that we are trying to find the minor of A11, then we can say the minor of A11 will be what we know. We generally neglect those rows and columns which lie in here. That means we have to neglect actually this row and this column, then we will get this part. So the minor will be A22, A23, A32, A33. If we determine this part, then we will get the minor of A11. Similarly, what about A12? When we are talking about A12, that means this, so this column and this row will be gone, so there will remain this and this. That means A21, A23, A31 and A33. Similarly, when we are talking about A13, then what will be happen? So minor of A13 will be A13. When we are talking about, then what will be happen? Then actually this and this will be neglected, then we will get this part. That means we will get A21, A22, A31, A33. Similarly, if we are just numerically think that if we are trying to find this minor, then this and this column and rows will be neglected. On that time we will get this two part and this two part. That means minor of A32, that means this and this are gone, then will actually remain A11, A21, A13, A23. So this is how we can find the minor for every parts. I think the students, you can understand how we can calculate the minor part, isn't it? So dear students, now this is the topic we are thinking for, that is the cofactor. Cofactor, what actually the cofactor is? Actually the cofactor actually determine the value of an entry is which sign it will take as well as which is its minor. That means it actually takes two part at a time. First of all, at the case of 2 by 2 matrix, one very important thing we know, generally 2 by 2 matrix, we are talking about first entry will be plus, second entry will be minus, third entry will be minus, fourth entry will be plus. At the case of 3 by 3 determinant, we generally talk about plus minus plus minus plus minus, then plus minus plus. Generally we are generally talking about the sign system should be this. But why the sign system is like this way? It is a very important question, and the answer of that is, if the matrix of a 2 by 2 is A11, A12, 21, a 22. Suppose we are thinking that this is our actual determinant, and from this determinant the entry of the position is, it is first row first column, it is first row second column, this is second row first column, and this is second row second column. And from this part, what actually we are going for, actually to find or the determine the cofactor sign has a formula. The formula is minus 1 to the power row plus column. This is the formula we have to have memorized when we are going for thinking the sign system. If it is generally minus 1 to the power r plus c, that means when we are talking about this position, that will be minus 1 to the power 1 plus 1, that means minus 1 to the power 2, that means 1. That means we get a positive value, that's why we are talking about positive. When we are thinking for this part, it is 1 2, that means when giving 1 2, that means 1 plus 2, it will be 3. Since it is 3, that means the odd number, then we can say this is a negative 1, that means we are using here the negative. When we are going for this position, it is 2 1, that means our row is 2, column is 1, that is minus 1 to the power 3, that is again we get minus 1, that's why we are giving here the minus sign. And finally, why we are going for plus? Because 2 plus 2, that must be 4, and then we get the positive value, that's why we give the positive in here. So one actually thing or one conclusion we can observe here, that is, if our position or the sum of the position is, or sum of the row and column is odd, then it is negative. And if the sum of the position or the sum of the row and column is even, then it should be positive. So let's have a look for the 3 by 3 what actually we found. So here, if we are thinking that determinant is 3 by 3, that is a 1 1, a 1 2, a 1 3, a 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. This is a determinant. How the system is works like this way. Look at that. Here is row is 1 and column is 1. So if we add these two, we'll get a even number. So it should be plus. Here is 2 plus 1, 3. It's an odd number, so it's minus. Here is 1 plus 3, 3 plus 1. That means it's a even number, so it should be plus. So 2 plus 1, 3, negative. 2 plus 2, 4, positive or odd. So even, that's a plus. Odd minus. 3 plus 1, even, that's a plus. 3 plus 2, what, odd, so minus. 3 plus 3, 6, it's a even number, so it must be plus. This is the sign system of the cofactor is. Okay, so just we are trying to understand how the cofactor sign works. This is the part. Now we are trying to find the cofactor for every position from 3 by 3 matrix directly. So dear students, what we are talking about, that cofactor generally come with two parts. So cofactor generally come from two parts. One is the signing system, that is multiply with the minor. If we multiply these two parts, then we get the cofactor. How? Okay, let's have a look. 3 by 3 determinant. So 1 1, a 1 2, a 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. Okay, so now we are starting to understand the cofactor from any position. So first of all, we are trying to focus on A11. What will be the cofactor at the position of A11? So cofactor of A11 should be what? Should be, first the sign will come. Which sign it will take? Yes, it should be -1 to the power 1 plus 1, that means it should be plus. We can understand already, that's why we can give here the plus sign directly. So plus sign generally don't need it to give, so we are just giving the plus sign. Then we have a minor, and the minor of A11 is what? We just neglect this column and this row, then we'll get A22, A23, A32, A33. Clear? So this is the cofactor from A11. Now what will be cofactor of A12 or 21 directly? What will be that? If we are trying to focus on this part, then the cofactor can be 2 plus 1. It's a what? Since it is an odd number, so it should be minus first. Then what will be its minor? The minor will be, since we are talking about this part, so this column and this row will be gone. Then we get the minor of A12, A13, A32, A33. This is the part how we can find the cofactor of A21 position. Similarly, if we are trying to find the another part, say for example A33, what will be the cofactor of that? It will be A33 will be, since it is 3 plus 3, it should be 6, and 6 is an even number, so it should be plus. Then for 3 position, these two gone, then it will be A11, A12, A21 and A22. Dear students, I think you can understand, all of you, that actually how these two or this cofactor works. So the cofactor is the combination of sign and the minor, and we can understand the minor, and also I think you can understand the sign system too. So dear students, we have already understand how the minor works, how the cofactor works, and now we move on to our main part, that is the determinant. What I was talking about, that determinant is a huge thing. We have to think it from the deep or from the core of your heart, that how actually determinant comes and why we are going for the determinant. Actually, determinant is something which is very important to understand the matrix, especially the inverse matrix or of any matrix is of its inverse is exist or not. So if the determinant is 0, then it will not exist, or inverse matrix is not available. But if the determinant of a matrix is non-zero, then the matrix will be invertible or inversible. So second fact is simultaneous system of linear equation has unique solution or not. If you determine to find the value of find the actually system of linear equation solution, is that unique or not? If you are thinking, then you have to go for the determinant. And third part is vector transformation. It is a very actually here is a huge field to understand the determinant, why the determinant is so important if you are trying to focus on the vector transformation. Though it's not your standard thing, but it has a very huge field to understand. However, most importantly, determinant can be done when the matrix is square matrix, because we have already seen two things from the minor and cofactor. On that time, one thing arises in your mind, that is this possible for a rectangular or something other matrix? Is not. No, matrix must have to be a square matrix. If the matrix is square, that means the row and column are same, then the determinant can be done or determinant can be found. This is the very important thing you have to know. So dear students, now we are focusing on the expansion part. So this is the determinant. Now we are going for the expansion, that how we can actually determine, or how we can find the value of it. Okay, it can be find by 6 ways. Actually, we can assumption, or we can assume for 3 column, 1 2 3, there is 3 column. You can take any of the column to find the value of it, or you may find, or you may think, or you may take 3 rows also. So we have 6 option to find the value of it. Okay, I will try to find here at least 2, and rest of the 4 you will be try, it is your homework. First of all, we are trying to find the value of it by taking first row. What is our standard thing or what we have generally done? Okay, when you're going for 1, that means we are taking 1, and when you write 1, then you have to think for the cofactor of 1. What is the cofactor? Since 1 is there, so the cofactor must be plus, so you may write here the plus, then the minus should be this, because when you're talking about that, so this column and this row will be gone, so we'll get only -1, 3, 2, 3. Now move on to next part, that is 2. When we are going for this position, the position of this part, for that part we generally know that the cofactor has the negative part, because it is the position for 1, 2 position, and we know the 1, 2, that means 3, and since it is the odd part, that is it will be negative will come, and then we'll get 2 will be, so this column will be gone and this row will be gone, we get 2, 3, 3, 3. And finally for -1, we'll write -1 directly, because this is the position for 3, 1, that is 3 plus 1, 4. 4 is an even number, so it should be plus. Plus into minus, it will be minus. So for -1, this column and this row will be gone, then we'll get this part, that is 2 -1, 3, 2. So this is the first line or the first part how we can find from here, and it is the combination of these elements into multiplying the cofactors. Okay, how we can multiply 1 into something, it will be obviously 1. How I write 1? So -1 into 3, it should be -3. 2 into 3, -6. -2 is there. 2 into 3, 6 minus 3 into 3, 9. -1 is there. 2 into 2, 4. -1 plus 3 into 1, 3. So here we'll get -9, then -3 into -2, 6, and here -7. Then we'll get what? Here will be just -1, so it should be -10. So the value of D is -10. So dear students, now again I have just written the same thing or same determinant, because of we are trying to focus on this column. We are determining this, just thinking for this column, or are trying to find out the value of it. Okay, so for 1 we'll write 1, and the cofactor of 1 we know that will be plus first, then we'll get, so this and this will be gone, so it should be -1, 3, then 2, 3. Here what will be the position of it? The position of it is 2, 1, isn't it? So it is a negative part, that's so we'll get negative, then 2 will be there, since we are talking about this part, so this and this are gone, so this will be not there, just we will get 2 -1, 2 and 3. Now we are trying to focus on 3, and what's the position of it? The position of it is 3, 1. It's again a even number, so we'll get what? Positive thing, positive 3, and we'll get on that time this and this are gone, and actually this will exist, that means 2 -1 and 3. And if we just multiply this, what we'll get? 2 into 3, -3, -6, and then -2, 6 minus plus 2, then plus 3 into 6 plus -1. Then what we'll get? -9, -16, here we'll get 5, 3, 15. So if we just thinking about, so it should be minus plus, so it will be again -10. So what I was talking about, we can find the value of it using actually what? Using the 6 method. So we are trying to find by 2 method, and you have option for second column, you can take third column also, or second row or fourth row, third row. So this is your homework, to find out every types of types of values or rows or column you should be taken care of. So now this is the way to find the value of the determinant. Now we are trying to focus on the determinant, where if it is non-zero or not zero, then it should be a what? Non-singular matrix, and if it is zero, then it will be a singular matrix, what I was talking about in this part earlier. So dear students, the formula to find a singular matrix, what's the definition for singular matrix? If the determinant is 0, that is the singular matrix. If the determinant is not 0, that is the non-singular matrix. These two are the definition, and definition is very easy but very important of its related math, that is we are talking about, that is 1C. Here we are going for question number 3. Here is given a matrix looks like this, that is alpha plus 4, then 8, then 2, and alpha minus 2. Here is the question says it is what is here the question says it will be singular for which value of alpha. For which value of alpha it will be singular. So how we can solve this math? We can solve this math like this way. If the matrix, suppose this is A, if A is singular, then what we can say, the determinant of A is equal to 0, isn't it? So here determinant of A is equal to 0, then it will be singular. So we can say alpha plus 4, then 8, and then 2, then alpha minus 2 is equals to 0. So how the determinant works? We know that multiply this with this, that is alpha plus 4 into alpha minus 2 into minus 16 is equals to 0. This is the way we can find. From here what we can write? We can write, if we multiply these two, then we will get alpha square, then minus 2 alpha, then 4 alpha, and minus 8, and here is minus 16 is equals to 0. So here alpha square minus or plus 2 alpha minus 16 plus 8, it should be 24. So here it should be 24 equals 0. So 24, it is 6 and 8, alpha square plus 6 alpha minus 4 alpha minus 24. Then if we take alpha as common, so alpha plus 6 minus 4 alpha plus 6 is equal 0. We will get alpha plus 6 alpha minus 4 is equals to 0. So from here we can write either alpha plus 6 equals 0 or alpha minus 4 equals 0. So alpha should be minus 6 or alpha should be plus 4. These two values find from here. So here we can say that alpha, the value of alpha will be minus 6 and or 4. So that's the answer we can say. So here the students, look at the board, this part are very important, it must have to be the determinant sign. Okay dear students, that's all for today. Hopefully this lecture is very helpful for you. Keep safe, stay safe. Thank you.